So I have been here in research, corporate research for Siemens for about 8 months. And before that, I was at Google. I was working also on R&D at Google. And before that, I was at Siemens, at Amazon, working also on R&D. But maybe it will be good to just tell you a little bit about what I do since I joined. Because I think many people think about research as publishing papers and filing for patents and working on new ideas with universities. And that is true, that is a big part of what we do. But what is important and what I really focus on is how to bring all of these ideas from the labs and from the research organizations to become products. And not only to become products, but to become products with impact. One of the critical things in what we do all the time is how do we make those products work in the messy world, that non-perfect world that we're living in. And that's where research really have an impact. And that's how I see our main mission as a corporate research. And one example that very close to my heart is robotics. I've been working on that for multiple different years in multiple different companies. And robots today, they are in all our factories. They are doing a great job. We teach them exactly the steps that they need to do. We write the script for them. And in any factories that you go and visit, you will see them executing like a clock and helping us in speeding up the process of development new products. So one of the things we're working on today is what we call flexible robots. And it's a step to autonomous robots. And the idea there is that like if the robot can have some intelligence, and we work very heavily on those, that it can detect that a sensor is dusty and can compensate from other sensors around it. It can detect that the product that's coming through the pipeline is twisted or warped, not in the exact same location, and can adjust to that, can understand this, can collect the data, can reason around that, and can decide, okay, here is what I have to change a little bit in my operation. So this whole process is, and instead of telling robots, do all of these steps, 1, 2, 3, 4, 5, until you come up with the final product, we tell the robot like what we want to achieve. We want to achieve this, and we let the machine decide how to do that, how to create all these steps in between, how to reason and decide based on the real data. So this is important because this is where really research can add a huge value. The standard products out there are working fine most of the time. How we can add the additional part of making it 100% reliable and addressing the what we call friction in the real world we're living in. That is really what I enjoy doing, and this is one example of what I'm doing, but that's what I'm focusing on. Not just to bring ideas to product, but bring product to impact and address the messiness that we have in the real world. We have tons of simulations, so if you think about it, about 18 months ago, there was this idea that we can actually teach robots by letting them watch us as humans, how we handle things. This behind the scene, there was this concept of something called VLA, Vision Language Action Model, Vision Language Action Model. And the idea there is that you put some intelligence in the robot enough to look at what you're doing and reason from that, and then can execute this by itself later on. The whole process requires first something called teleoperation. And teleoperation is basically humans doing the task multiple times, hundreds and hundreds of times. And the robot absorbs all of this, and that's how we fine-tune the model. That's a VLA model, the Vision Language Action Model, in order for it to understand how to deal with certain variations. And this is part of the process. So you start from creating the model, it's an AI model, and then you pre-train the model, then you fine-tune the model based on all of these teleoperation, and then you take it and put it in the factory or in the lab or in the environment, and you start observing how the model is working, and then you can create a closed loop simulation. And the closed loop simulation basically is there is a perception, the robot itself have a lot of sensors and it can actually perceive the environment around it. And based on that, based on the real data that's coming, it can adjust the action that it needs to execute. So we do that a lot. The area of creating what is now common in the industry as autonomous robot is still a research topic. It doesn't exist in reality yet. What we have today in some of the factories that you will visit, I heard that you're visiting factory in Arlington tomorrow. Actually, we have few of those that's coming from my lab that are on the show floor, on the factory floor, doing actual work in production. And we call them flexible robots because they are not completely autonomous yet. But they are not pre-programmed. You don't program all the steps. You actually give them a job and tell them figure out the steps in between, and they can do that. So there are two pieces. When we talk about software in robotics, there are multiple pieces of that. One of them is the brain. So the brain is basically the robotics foundational models, the VLA, all of this intelligence that needs to handle. But then there is also the software that we need to connect the whole machine, the robot itself, in the whole pipeline of automation. So it can be commissioned, it can interact with other machines and all of that stuff. So that's the software. The software inside the robot, software outside the robot. That's what we focus on. The hardware, we haven't entered that yet. So the first stage that we are very serious about is flexible robots. So because we see a value in doing this. Like ultimate value at the end is to create a humanoid that can act and just replace a factory worker, for example. We are not there yet, but the flexible robots themselves, the cobot arms that are flexible, we see a huge value in doing this. And those are already out. They are already on the factory floor that you will see tomorrow, and you will see them in action. And it's a continuum, it's a spectrum. So this is the first thing that will come because we are confident about this one, but then we are still working on the final goal of autonomous ones. And these are still out. We still have some time because it is very messy outside. We cannot predict everything. There are, like, one of the biggest challenges, there are two challenges, just to be clear about autonomous robots. One challenge is to create the intelligence, to deal with all of these different things. And that's still a research topic. There are lots of companies working with this and lots of universities working on this. And we are very close with, for example, the University of Berkeley in the United States, in California. And we do a lot of joint research with them on the VLA, on the Vision Language Action Model. So that is one area. And then the other area is on data collection. If you think about language model, large language models that are developed now for your chatbots and Gemini and all of these great products that we are all using today, they were trained on the internet data. So you can go to the internet and get all of these huge wealth of information available in terms of video and text and all of these things, and just train those models. Now, when we try to train our robots, we need examples of somebody actually soldering a PCB, like some of these electronics components. Where do we get that? These are not like videos available online. There are not millions and millions of those videos available online for all different variations. So we have to create those. We and everybody else in this area needs to create those. And that's very expensive. You basically need a human to stand and just show the robot what to do for every single use case that you want to create. And because of that, the data is a bottleneck. And the data is a hurdle for everybody working in this area. The way to handle this, of course, is to focus on fewer use cases. And that's why we started with flexible robots, because these are focusing on few use cases, so we can train them. And we can equip them with the data and the intelligence needed to do that, and we let them do that in a reliable and high success rate. To make them fully autonomous, that's going to take a lot of work and a lot of data.